look at a problem and solve it using a big F method. So first of all, big F method, the algorithm or the procedure of a big F method is same as that of what we have done in the previous class. That is for a simplex method. What all things that we have done, it is very much similar. There are, of course, there are a small changes towards the with regards to the simplex method. Now, what is that difference between a simplex and a bigger method? Now, for that, I just want to show you an example. Now, in this example, you can see that this is a minimization problem. Plus, when you have a closer look at the constraints, you can see that the inequalities are of a greater than or equal to sign. Now, in a simplex method, you have studied the constraints, or you have worked out the problem with the constraints having less than or equal to inequality. Now, at that in that case, what you have done is you used to add slack variables. Whenever you get an inequality like this, what is the thing that you used to do? You add slack variables to the constraints, right? So, but in the case of this, that is in the case of greater than inequality, what you do is you subtract the surplus variable, subtract the surplus, sorry. Okay, and when you subtract the surplus variable, say if it is minus s, we will have to add another variable called as the artificial variable, a. Okay, so this is what you have to do with regards to the constraint. Now, when it comes to big M method, what is this M? What is that you have to do with this M? We will see about that in the coming steps. So let's start the problem. Now, the first step is again to modify your constraints. So let's see how you can modify your constraints. So I'm leaving a space over here so that I can write the objective function, modified objective function. So let's see what I will do with the constraints. So our constraint here is 2x1 plus 4x2 plus 6x3, and what I'm going to do is, as I said earlier, I'm going to subtract a surplus variable and add an artificial variable. Then I make this as an equation. I'm sorry. Then what about the next constraint? 3x1 plus 9x2 plus 6x3 minus s2 plus a2. Okay, this is equal to 30. Now, whenever I make a change in the constraint, I hope you know that I used to make a change in the objective function too. So what all changes or what all things I'm going to add to the objective function? Let's have a look. And here comes your M. Now, why is it set as big M? You're going to introduce an M to this objective function, and M is a very large positive quantity. Okay, very large positive quantity. So again, how will I introduce that? You can simply introduce that, but you will have to do some technicalities over here, not a big complex technicalities, but yes, let's see what I'm going to do in the objective function. So here I'm going to introduce my surplus variables like s1 and s2, and what I have done over here is the coefficients of s1 and s2, I have kept that as 0. Okay, so you should take care of this while using the big F method for solving a certain problem. Then I'm going to introduce the artificial variable also over here, a1 plus a2, and now here comes your m. M will be a very large, M is a very large positive quantity, and M is the coefficient of your artificial variable a1, and the same M is also the coefficient of your artificial variable a2. Okay, so this is how you start a problem by start a problem if you are asked to use the big M method. So first what you have done, you have done some modifications on the constraints. You have subtracted a surplus variable, and you have added what, an artificial variable to it. Then the same changes is applied to the objective function, where you should take care of this surplus variable. Why? Because the coefficients, have a look at this, the coefficients of this surplus variable is written as 0. And what about the artificial variable? The coefficient of the artificial variables a1 and a2, I have introduced a very large positive quantity named as m. I hope till now this is clear. Now this is of a standard LP problem, and now you will be creating your initial table. So let's have a look how to create the initial table. Okay, so CV B XP X1 X2. In this case there are three variables, X3, S1 other than the surplus and artificial variables, A1, A2, and a last column the ratio or minimum of xp by xi's. Okay, now just draw a line. You have to write Cj over here, then Zj, Cj minus 1, Cj minus Zj. So the procedures all are the same, but as I said, there are minute differences between the simplex and the big M method. Now here what I'm going to do is, in the Cj part you have to introduce the coefficients. Now what are the coefficients? Just have a look at your objective function over here. 7 for x1, for x2 it is 15, x3 it is 20, s1 it is 0, s2 it is 0, for a1 it is m, for a2 also it is m. So here you have to write this as what, 7, 15, 20, 0, 0, capital M, capital M. Now here in the basic variables we are going to introduce the artificial variables a1 and a2. Okay, then xb. I hope you know what is xb, the right hand side of your inequalities. So it is 24 and 30. What is the coefficient of the basic variables? It is m and m. Now what about this table? It is 2, 4, 6, minus 1, 0, 1, 0. Now in the next line, 3, 9, 6, 0, minus 1, 0, 1. Now you have to find out Zj. Now how will you find out Zj? The usual method. What is the thing that you have to do over here in order to find out Zj? You have to multiply what, 2 into m plus 3 into m. What is it? 2 into m plus 3 into m. So you get over here 2m plus 3m. What about this 4m plus 9m? Now instead of writing 2 into m plus 3 into m, you can write what is that, 5m, right? So I'm going to write that as 5m. Now what is this, 4 into m plus 9 into m, 4 into m plus 9 into m. So all these procedures have been done earlier, right? So what is 4 plus 9? 13m. So 13m. What about the next value? 12m. Then minus m, m and m. Now what is Cj minus Zj? Cj minus Zj is 7 minus 15. 7 minus, sorry, it's not 15, it is 5. 7 minus 5m. What about this 15 minus 13m? 20 minus 12m, and this is will be m minus m and sorry m and this will be m minus m, that is 0 and 0. Now see, we have completed this table. Now we have to find out the key column, key row and key element. So how will you find out the key column and key row? Now this is a minimization problem. So up to now what you have find out is, for a maximization problem there was a there was a rule set for that. Now, similarly you have a rule set for finding out the column in case of the minimization problem. Now let's have a look at that. Now in order to find out the key column, what you have to do is you have to find the largest Cj minus Zj value, largest Cj minus Zj value which is less than 0. That is the largest negative value that you can get for Cj minus Zj. Now in this case, when you look at these values, you can't take this, these are all positive and these two are zeros, so you don't have to check these 4 values. But what about this? Now in the beginning I have said that m is a very large quantity, so 13 times m, so if I write these values as minus 5m plus 7, fine, minus 13 times m plus 5, plus 15, minus 12m times plus 20, which is the most negative value in this case, in this 3 case? Yes, obviously this one. So our column, that is the okay, so here the largest negative value, that is Cj minus Zj, is this one, right? So that is minus 13m plus 15. Okay, when you multiply, as I said before, when you multiply minus 13 with a very large quantity, that is m, you will get a negative quantity, that is again a very big quantity, very big negative quantity. Okay, so with that we will be identifying our column, and this is our key column. Okay, now again for identifying the key row, what is that you have to do? You have to divide 24 divided by 4, which is equal to 6, and then 30 by 9, which is equal to 10 by 3. So here this is your key row and 9 is your key element. So again, for the next table, what is the thing that we have to do? Yes, you have identified your key element, that is 9. So you have to make this 9 as 1. So let's have a look. Again, you draw your box, the table. So so this is our table. So as I said before, now let's see which column will enter. Okay, now this is the key column, sorry. So x2 will be entering, and x2 will be entering, the variable x2 will enter, and a2 will exit. Okay, so in the next table, it's x2 and a1. Write down the coefficients m, 15. Now what about the table? So as I said, we have to make the key element 9 as 1. So I will have to divide this particular row including 30 by 9, so that you will get this key element as 1. Okay, so let's see what I will get when I divide 10 by 3, 1 by 3, 1, 2 by 3, 0, minus 1 by 9, 0, and I'm going to put a dash over here since a2 has gone out, so you don't have to consider this variable anymore. Now what about the first row? So let's see, when this 9 is the key element and you have made this as 1, the element which is above the key element should be 0, or you have to convert this into 0 in your next table. So this I leave it to you. You just do some basic calculations and you will get the value. This has been already explained when we were doing our simplex method. Again, this a2, the element that comes under the variable, artificial variable a2, I have not considered it. What about xb over here? It is 32 divided by 3. Okay, now again you have to find out zj. So how will you find out zj? 2 by 3 into m plus 1 by 3 into 15. So let's see what I will get. 2 by 3m plus 1 by 3 into 15 is 5. Okay, then next value 15. Please calculate that and see whether you are getting the answers. 10 by 3m plus 10 minus m, 4 by 9 m minus 5 by 3, and corresponding to this m variable, a1, it is m. Okay, so what is zj minus cj? Zj minus cj is minus 2 by m plus 2, 0, minus 10 by 3m plus 10, then you have m over here, cj, so 0 minus m is m, Cj minus m is m. Then next value, minus 4 by 9 m plus 5 by 3, and this one is m minus m 0. Okay, now just consider these values you can't consider because they are all either positive or 0 values. Now what about this minus 2 by m minus, sorry, this is minus 2 by 3m. Okay, minus 2 by 3m plus 2. What about these values? This and this, and yeah, so you have to find out the column. In order to find out the column, you should find out the what largest negative value. So the largest negative value over here is what, this one, right? So this is your key column. Now what about the key row? In order to find out the key row, you get 10 by 3 divided by 32 by 3, that is 16 by 5. 2 by 3 divided by 10 by 3, you will get 5. Okay, so this is what you have got over here, and the minimum value is of 16 by 5, and that you can mark this and with the help of that you can mark the key row, and you have got the key element. Now let's have a look at the next table. So this is our final table. So what I have written over here, okay, now let's have a look at the key column. So in the key column, we know that x3 enters and a1 exit. Okay, so our next in the next table we have x3, x2. This a1 and a2 variable, since they are not important anymore, we have kept blank spaces for them. The coefficient of x3 and x2 is written over here. Then what I have done is the key element is 10 by 3, so I have multiplied the key element with 3 by 10 in order to make it as 1. So when I multiply the key element 10 by 3 into 3 by 10, it is very much necessary that the first row, that is this row, should be multiplied by 3 by 10. So I have done that also, and again these are the answers that I have got by multiplying 3 by 10 in the first row. Check whether you are getting the same answer. In the second row, again, since this is the key element and I have made it as 1 in the next table, what about this element? You have to make this element as 0. So please do the necessary steps for making this element as 0. That I leave it to you. And yes, so this is the final, this is the second row, and after that you will have to find out what zj. So how are you going to find out zj? So zj, you can find it as what? Yeah, in the same old method that you have adopted in the previous tables. Then you can find cj minus zj, where you get these values. Now this is where you can stop your iteration in a case of a minimization problem. So the optimality is reached, in a place where all these cj minus zj values, all the cj minus zj values are positive or 0. Okay, now here you don't find any negative value, so all the elements over here are either positive or 0. So that is where we reach our where we can stop our iteration, and from that we can arrive at another conclusion, which is the major aim of our problem. We have to solve, we were asked to solve, and we have to find out the unknown factors now. So here x2 is 6 by 5, x3 is 16 by 5 from the tables. X1, which is not in the table, is 0, it's considered as 0. And what about the objective function? We are asked to minimize z is equal to 7x1 plus 15x2 plus 20x3. So this is equal to 7 into 0 plus 15 into 6 by 5 plus 20 into 16 by 5, and you will get the answer as 82. So this is your final answer, and I hope you have understood the problem, and see that this we have done this for a minimization problem. The same method, the same became method can be done for a maximization problem also. Regarding that, we will do another video. Thank you.